Welcome to qnawire.
To figure out the half-life from the information given, we need to first calculate some numbers that will help us determine the half-life. The first one is the rate constant, or the activity constant. We can get this knowing the activity and knowing the number of radioactive nuclides that are present. The activity was given to us at 1.5 times 10 to the 5th becquerels, or 1.5 times 10 to the 5th decays per second, which is a becquerel. K we don't know, but we do know the mass of the radium-236. That was given to us as 5.4 micrograms. 5.4 micrograms are 5.4 times 10 to the negative 6 grams. We can then convert the micrograms of radium chloride into moles of radium chloride by calculating the molar mass of radium chloride. And the best way to do this is to, since this is a radium-236, we don't know the specific mass of that particular isotope, so we could just use 236 for radium and then use the average atomic mass of chlorine for the two chlorines that are present. So it'll be 2 times the average atomic mass of chlorine plus the 236. That gives us 296.9 grams per mole of radium 236 chloride. We can then convert the moles of radium-236 chloride to actual number of radium-236 units, formula units. But because there's one radium-236 in each radium-236 chloride formula unit, then once we get to this point, we have calculated the number of radioactive nuclides. So we will then multiply all of these together over here. We'll still have the 1.5 times 10 to the 5th decays per second. That'll be equal to K. And then what we get over here are the number of radium-236 chloride formula units, which is also the number of radium-236 nuclides. We then divide these two numbers in order to get our K value of 1.37 times 10 to the negative 6 1 over seconds. Then to get our half-life, the natural log of 2 divided by the activity constant, which we just calculated, 1.37 times 10 to the negative 11 1 over seconds, will give us the half-life then in units of seconds. This is unitless. This has units of 1 over second, so 1 over seconds is just seconds. And we get 5.06 times 10 to the 10 seconds, which we can convert to a more reasonable time unit, such as years, by recognizing there's 3,600 seconds in an hour, 24 hours in a day, and 365 days in a year. This then gives us, for the 5.06 times 10 to the 10 seconds, a value of 1,605 years, being the half-life of this substance.